Okay, hello again. Follow up from yesterday's video. So I made a claim yesterday that Peta-blocks not happening are impossible, and that people who are claiming to have mined these blocks are misinformed and spreading misinformation. So that was yesterday's claim. I'm back today to refine that. So I'm right and wrong. Okay, there are some P order blocks. They're extremely rare. They're hard to find, and actually, one of them really did come from CK Pool. However, that block was reported to have double the difficulty that it actually had. So that's why I say I'm both right and wrong, and this needs some follow-up, some more clarification. As miners, as Bitcoiners, we need to understand how this works. It's not okay to just like at a dashboard as I was saying, you want to be able to verify stuff yourself, and you want to know how it works. So this eviction notice here, I'm going to talk about difficulty. Okay, so what is even meant by proof of work? What is that, right? What's proof of work? Well, it works like this. The only objective measure of a block's difficulty is its hash. That's the hash of the block contains all of the information of the block encoded. So you don't need to query the pool or the miner or any of that to validate the difficulty. The block hash is being treated as a number with a certain magnitude. So if you're not familiar how binary numbers are converted to decimal, they're read from left to right, and each binary position is a power of 2. So the rightmost number, last part, let's say a hash string, 64 hex character hash string, is going to be the 2 to the power of 0 value, and then the second from the right will be 2 to the power of 1, and it's either going to be off or on. So every binary number works like this. Like you start from the right, and that 2 to the power of 0 field is either off or on. If it's on, you score a 1. If it's off, you score a 0. And then you move, and you have the 2 to the power of 1 field, and it's either off or on. and you work your way to the left, and that leftmost, that leading binary digit is to the power of 256. So it's either off or on again, and that's so. But even these enormous binary numbers can encode like megalithic direct decimal values. That's how binary encoding works, and computer scientists are going to understand that. Anybody who has seen any of my other Bitcoin stuff is going to be familiar with that. What are we trying to say? That entire hash just gets treated as a number. And for your block to be accepted by the network, it has to be small. So the smaller a hash is, the more difficult it is to solve. And that difficulty is represented by leading zeros, because in a binary number, its magnitude is going to be determined by the leading zeros. Like as soon as you hit a 1, that's a power of 2 that is like excited, it's on, so that value exists. So when you're looking at a 256-bit hash, and you have leading zeros, like after you want about like 80 zeros, let's say, that you still have 200 or 176, 2 to the power of 176. Is like 9.5 to the 52nd power, so there's 52 orders of magnitude of hashes that are smaller, even when you have 80 leading zeros. There's a lot of room here to the power of 256 total. 10 to the power of 77, something widely reported somewhere around the number of atoms in the universe, 256 bits. So proof of work. What is proof of work? It's on average, you're not going to just grab a very small hash. Every 10 minutes the clock resets, the miners start again. And they start from scratch. There's no the only database is the blockchain. They start from scratch and they tweak the block parameters. They tweak the block parameters and then hash it until they hash the entirety of that space. And then they change the block parameters and hash some more. And they continue to do that until they're able to tweak it in order to get the hash that is small enough that it is under the network difficulty. The point is that you can calculate a block's difficulty from its hash. So yesterday, after I made my claims that P-blocks are impossible and whatever, I went to look into it some more, and I started looking at the Genesis block, or I argued with the chatbots first, and then the Genesis block has 10 leading zeros in hex, but it has a difficulty of 1. I think it's a special block. Every block from block 1 all the way to like block 32,000. So like full year, the difficulty was 1. And those blocks have 8 leading zeros. in hex, they all do. So it's 32 bits. So it works like this. Difficulty of 1 is 8 leading zeros in hex. So your hash is going to look like whatever, right? It's going to have 8 leading zeros in hex. When you see that, that's 32 bits. That's the difficulty of 1. So what we're going to do is we're going to count the leading zeros, and we're going to subtract 32 bits. Call it Z. It's 2 to the power of Z minus 32. That's going to give you an order of magnitude that is roughly your difficulty. We're just looking for heuristics here, not exact calculations. I want to be able to assess a block's difficulty very quickly to see, is this a P block? Is this like, what's the actual difficulty here? So that basically you want to count the number of leading zeros, but then also there's the next nibble, it's called, which is a hex character, a half a byte, may also have some zeros. Like 1 has 3 more zeros in binary, so you just want to make sure you have a true count of your leading zeros in binary. So every hex 0 counts for 4. So you take your hex zeros, multiply by 4, and then you just check your next nibble. If it's like a 1 or a 2 or a 3, then there's going to be more leading zeros. So you have to be fair that you need the number of binary leading zeros. And that's what I'm calling Z here. So it's a very simple equation actually. Minus 32. 2 to the power of Z minus 32. So if there's 83 leading zeros, that's 2.25 T. I mean P. Quadrillion, 2.25 quadrillion. That's a hash with 83 leading zeros. 82 leading zeros is 1, it's half that size. Every additional zero doubles the difficulty. Because their powers are 2, so every place is double the magnitude. So we have that again. Let's just go to 79. 79 leading zeros in binary is 140 trillion. That's the current network difficulty. So for a block to be satisfactory, you need 79 leading zeros. And that's all there is to it. So if somebody makes a claim that their block is P order, right? You don't need pool stats. You don't need a screenshot from them. You don't need any of that. You need your own blockchain. That's all you need. You can open mempool on your local area network in your own blockchain. You can go to the block yourself that the person claims. You can look at the hash, and then you can count the number of leading zeros. You can magnitude of the hash, and you can see for yourself. So what I have learned is that almost all of these P order blocks are not real. There is perhaps one out there that had, what was it, 82 leading zeros, which gives us to the power of 50, which is 1.125 quadrillion, or P. So the claim I made that it's impossible, that they don't exist, is wrong. However, the claim that I made that mining pools are falsely reporting share difficulty, and that people do not understand the difference, or are taking their pool's reported share difficulty and saying this is how difficult my block was, that claim is true. That's bullshit. That's happening. I went too far to say that P order blocks don't exist yet. They do. They're extremely rare. I stand by my claim that this is just physics, thermodynamics in action. The probability that you're going to find a hash with, what do we got here, 82 leading zeros compared to finding a hash with 79 leading zeros. There are just so many more hashes with 79 leading zeros. It's not just you finding it. It's a global competition. So for a P order block to even exist on the network, that means that somebody found the P order hash before anyone else in the world found any of the hashes in the order of 100T. So like with 70, let's say 79 leading zeros instead of 82. So the takeaway from all this is that trust, don't verify. No, don't trust, verify. And like, we're close, but it's not actually happening that much. Like, it happened like, once. And even the one where I'm saying, okay, there is a block of 1.12 P. That block was reported as more than double that. So it is happening, but it's not as severe as I implied yesterday. The most important thing is to just be sober about it and understand how to calculate it and what it's doing. So what is proof of work? What is meant by proof of work? The only proof of work technically is like temperature, right? Heat. But we can't quantify that. We quantify it by the hash difficulty and the statistical distribution. That is, we're going to more or less on average find these hashes in order. You're not going to jump around. You're going to find almost all of the hashes with 1 0 before you find very many with 2, etc. And you're going to find almost all of the hashes with 79 zeros before you start finding very many that have more than that. So, like, the outcomes are going to cluster, and mostly they're just going to eke under. The blocks are almost always going to have a target difficulty that is very close. And that's a really important thing to understand.